Welcome back, my mathletes. Today we are going to take a look at the powers of products and quotients. Meaning we are going to raise two things that are multiplied to a power. So we're going to be dealing with exponents raised to another exponent. And it's a lot easier than it sounds like it's going to be. If you can multiply and you can handle the distributive property, you are going to be in good shape. The last time we talked about the exponent rules. We looked at multiplying like bases, we looked at dividing like bases, and we looked at adding and subtracting like bases. We are going to put most of that to good use today. Now, on the first one, I'm going to do this two different ways because I want you to see what's actually happening first. Then we'll talk about the rule. It's been a little while, but we talked about how x squared meant x times x. So I'm going to use that idea to take care of this guy. The parentheses and the 3, just like x squared told me to write x 2 times, the 3 tells me to write everything in the parentheses 3 times. So I need a 3s squared times 2s squared. So that's 1. And I'm going to cheat a little bit. Maybe I'm not. Let's see. There it is. So I write everything in the parentheses 3 times. So I'm going to do a little bit of simplifying. When we multiplied like bases, we took the coefficients of those bases and multiplied them together. So that's what I'm going to do inside each set of parentheses. I know 3 times 2 is 6. And I have an s squared and an s squared. And that's going to be the same in each of these. So I'm going to get a 6s squared, s squared, and a 6s squared, s squared. I'm going to multiply my 6's. 6 times 6 is 36. Thirty-six times 6 is 216. And then yesterday we talked about when you have like bases and you're multiplying, you add up your exponents. Well, I have a whole bunch of s's and they all have exponents, so I'm going to add up the exponents. I have 2 and 2 right here, so that's 4. And 4 more is 8. And 4 more is 12. So this is 216s to the 12th power. Now that wasn't too bad. It was a little bit drawn out. It would have been a lot worse if the exponent on our parentheses had been a 5 or a 6 or a 7. So that method is okay as long as your exponent is fairly low. Now let's look at how to use the rule for raising exponents to a power. So let's I'm going to shrink this a little bit and move it up out of the way. And we're going to give this a big old OR. Now, if you want to use the rule to raise an exponent to a power, we're going to multiply across the parentheses. So if we have x squared to the third power, this is x to the 2 times 3, which is the same as x to the 6th. So that's the idea we're going to apply on our second option. I'm going to do our second choice in green so you can differentiate easily between the two methods. Now, the first thing I notice in number 1 is that the 3 and the 2 could be multiplied. So let's start inside the parentheses, just like if we were doing PEMDAS. I'm going to bring down my parentheses and their exponent. I don't like the way that one looks. I know 3 times 2 is 6. And then I have the s's. I know I said it was going to do it in green. I'll switch it in a minute. I have like bases, so I can add the exponents. That leaves me an s to the 4th. Dang it. There we go. Now, the next thing I notice, I'm going to clean this up a little bit, is that my 6 does not have an exponent, or at least it appears not to have an exponent. But because you were all excellent mathletes, you know that if there appears to be missing an exponent, all you have to do is squeeze in a little 1. So now I'm going to go up and I'm going to apply the rule that says multiply across the parentheses. But this is just like when we did the distributive property, where we tried giving giving an ice cream cone to only one of 2 kids, and we know that did not turn out well. So we have to make sure we multiply to both the 1 and the 4. So this becomes 6 to the 1 times 3, and s to the 4 times 3. Well, I know 1 times 3, and I know 4 times 3. The only step left is to simplify that 6 to the 3rd power. And I know from sneaking in a little Desmos action a second ago that this is 216 s to the 12th. So regardless of which method you use, you wind up in the same situation. I put in some baby steps in that one. Once you get comfortable, you can leave out the baby steps. If you get an answer where you think, that doesn't look quite right, you can always use this first method to write it out and add them up and see if you got it right. Let's do one that's a little bit different. Look down at 4. This time I'm only going to use the product rule. The first thing I notice when I look at 4 is that my 2 doesn't have an exponent and my z doesn't have an exponent, so I'm going to give them 1. If I go in and physically write those in the correct place, I run a lot smaller risk of making an error than if I try to just do it in my head. So I'm going to have 2 to the 1 times 4 power, h to the 5 times 4 power, and z to the 1 times 4 power. Baby steps until we can take off the training wheels. So this is 2 to the 4th, h to the 20th, z to the 4th. To simplify, I know that 2 times 2 is 4, times 2 is 8, times 2 is 16, h to the 20th, z to the 4th. And that, friends, is our final answer. In class, I asked for any requests on the multiplication section, anything that might make you feel a little twitchy. And I was waiting for it, and they did not disappoint. This one was requested. Anytime there's a whole long string of stuff in the parentheses, I look to see if I can simplify it. And sure enough, I have 2 constants that I can multiply. So I'm going to bring down my parentheses. 3 times 4 is 12. I also notice that I have like bases, so I can add the exponents. I'm going to give a little 1 exponent to my middle W. I know 3 plus 1 is 4, plus 2 more is 6. So I get W to the 6th power. I'm going to slide this bad boy over a little bit. Now I'm going to give a 1 to my 12. And I'm going to distribute that 2 to everybody. So I get 12 to the 1 times 2 power. And W to the 6 times 2 power. So that's 12 squared times W to the 12th. So I get 144 W to the 12th. So now let's go practice on the division side. We'll start out little. We'll start out with just numbers so that you can do it by hand and then plug it into your calculator if you want to double check. Now remember when we simplified the quotient, the answer to the division problem, when we had like bases, we subtracted the exponents and we did top minus bottom. So just like with the multiplication ones, I'm going to do the inside first. So this is going to be 7 to the 4 minus 1 because I did the top exponent minus the bottom exponent. So this is 7 to the 3rd to the 3rd power. Now I can use my quotient or my power rule to multiply the 3's. So this becomes 7 to the 9th power. And I love you guys, but I refuse to put that into my brain. It might have a meltdown. So this is 40,353,607. That escalated quickly. Let's take a look Let's do one with some letters. Let's do 9. Now I picked 9 for 2 reasons. 1, it has variables. 2, the numerator and the denominator both have a constant in them. So this is a great review from the last class we had. So I'm going to simplify the inside first. If you remember from the last class, when I simplified a quotient using variables and exponents, I separated them into two fractions, which is perfectly legal. If you don't believe me, stop by sometime and I'll prove it to you. That way I could see that I have a fraction right here, and it made it easier to reduce without the distraction of the variables. Well, I know 8 divided by 2 is 4. Now I'm going to look at the C's and simplify those. So I will have 4 times C to the 5 minus 1, top minus bottom. So this is 4C to the 4th squared. I'm going to add in an exponent for my 4. Now I'm going to distribute the 2, so I'm going to multiply the 2 times the 1. So this is 4 to the 2nd power. Then I'm going to multiply 2 times 4. That gives me 8. I know 4 squared, that's 16. C to the 8. Now I am going to shrink this . And we'll go look at 10. You guys know that I tend to pick my problems strategically. And I definitely have a reason for picking 10. On the other ones, the variable with the higher exponent has been in the numerator. Now it's in the denominator. And I want to make sure we get one of these in here because it's a great review of the skills we talked about during the last class. So I'm going to leave the parentheses in the 3. If we do top minus bottom, I need to give my little top h a 1. So I get h to the 1 minus 5. That's where our difference is. So this is h to the negative 4th, all raised to the 3rd power. Now I'm ready to multiply across the parentheses, so it becomes h to the negative 12th. But you guys learned that anytime you have a negative exponent, you have to rewrite it. We need positive exponents. So I'm going to sneak in a 1 so that I can make h to the negative 12th over 1. I have a fraction. And we talked about how when a variable in the numerator has a negative exponent, it moves to the denominator and the exponent becomes positive. And we'll leave the 1 on the top. And it's not real pretty, but that's our final answer. As with anything, remember I am always around to answer questions, so if these are getting to be a little much, absolutely come by and see me. I think, were there some scarier looking ones somewhere? Yes. Oh, no, I think that's as scary as they got. Okay, well, until I see you again, I bid you good day.